first way we went about graphing a function was to make a table, come up with some inputs, some x values, figure out the y values, and then plot the points. We'd plot 1, 2, 3, 4, 5, maybe 6, 7 points, and then we would connect them all in a straight line. Now, there are other ways to graph a line, a graph being the collection of all possible solutions, where a solution is an ordered pair that makes the equation true when you plug it in. And here's the thing. You only need 2 points to define a unique line. Any 2 points you draw, when you connect them, they define one line. There's no other line that passes through both of these points. This line, the original one that I drew right here, this line right here is the only line that goes through these 2 points, A and B. The key being A and B can't be the same point. So when you're given an equation, all you really need is 2 points in order to draw the line that represents the graph of that equation. Theoretically, you could try to find any 2 points, but there are specific points that are generally easiest to find. Those points are the intercepts of a function. The y-intercept is when the value of y when x is 0, and the x-intercept is the value of x when y is 0. So here is your y-intercept. It's where the function hits the y-axis. It's where it hits the y-axis, right there. And right here is the x-intercept. It's where the function hits the x-axis. You hit the y-axis when x is equal to 0, and you hit the x-axis, you hit the y-axis when x is equal to 0, and you hit the x-axis when y is equal to 0. So if you're asked for the x-intercept, remember that the x-intercept is the x-coordinate of the point where the graph crosses the x-axis, and the y-intercept is the y-coordinate of a point where a graph crosses the y-axis. The reason why we look at intercepts is because it's really easy to plug in the number 0 into a function. 0 times anything is 0, so you don't have to worry about a lot of fractions that you might have to run into if you went after a different set of points. So for example, on this line right here, there are many other pairs of points that define the same line. We could have, I don't know, that point right there and this point right here. Those 2 points, when connected, can form the same graph as the 2 intercepts when you connect them, but they are harder to find. So let's say you were asked to graph the equation 3.5x plus 7y is equal to 14. You're going to find 2 points, and the 2 points we are going after are the x-coordinate, the x-intercept, and the y-intercept. So if we go after the x-intercept, keep in mind this is when y is equal to 0. So what we do is we plug y equal to 0 into this equation. So now we have 3.5x plus 7 times 0 equals 14. All we've done is we plug y is equal to 0 in for y. Well, 7 times 0 is 0, so we're left with 3.5x is equal to 14. We need to isolate x, so x is going to be equal to 14 over 3.5. Now, you know that that's not a form I want you to leave the answer in. So a great way to simplify that would be to turn 3.5 into the fraction 7 over 2. So you get x is equal to 14 divided by 7 over 2. And you know that dividing by a fraction is the same thing as multiplying by the reciprocal, so 2 over 7. So you end up with 14 times 2 over 7. Well, 14 and 7, they have a common factor of 7. So this cancels and becomes 2. So you end up with 2 times 2 is 4. This tells us that the x-intercept is 4. That's the point when y is 0. So the point is 4, 0. That's where it crosses the x-axis. Now, if we want to go after the y-intercept, that's when x is equal to 0. We're going to do the same exact thing, but we're going to make x 0. So that's going to be 3 times 0 plus 7 times y is equal to 14. Again, what's really nice about this is that 3 times 0 is 0. So we just have 7y equals 14. To isolate y, we divide by 7 on both sides, so we have y is equal to 2. So this tells us that the y-intercept is 2, so when y is 2, x is 0. So this was the y-intercept, and we know that up here we have the x-intercept. Now to make a graph, all we need to do is plot those 2 points and connect them. Keep in mind when we make quick graphs, they don't have to be super accurate, so don't obsess over so much of the detail. So 4, 0, and 0, 2, that's the first quadrant. So I'm just going to draw a first quadrant set of axes, like this. And let's say that was 2, 4, and 6, and this was 2, 4, and 6. And we know that the x-intercept was 4, 0. So the x-intercept was 4, 0 right there, 4. And the y-intercept was 0, 2, right there. So all you do now is you connect the two, and that right there is your graph. What about this equation, y equals 4x plus 40? If we go after the y-intercept, remember this is when x is equal to 0. So that's going to be y equals 4 times 0 plus 40. So the y is equal to 40. So our intercept is 0, 40. That's our x-intercept. Sorry, the y-intercept. If we wanted the x-intercept, that's going to be when y is equal to 0. So that's going to be 0 equals 4x plus 40. Subtract 40 from both sides and get negative 40 equals 4x. Divide both sides by 4 and you end up with negative 10 is equal to x. So that means when x is negative 10, y is 0. Now choose the appropriate scale to graph this. Again, we can use all 4 axes if we want to, but you can choose the proper scale. We don't need to put out 1, 2, 3, 4, 5. Let's go by tens. So let's say that's 10, 20, 30, and 40. So negative 10, negative 20, negative 30, negative 40. And we can finish this. So 0, 40, where is 0, 40 going to be? That is the y-intercept. That's going to be at 0 for the x and 40 for the y. So right there. And then what about negative 10, 0? That's going to be right there. So now what we do is we connect the two. We end up with this steep line right here. There's your quick graph. So the things to remember are that any 2 points that are not equal define one line. All you need is 2 points and you have one line. You can't draw two different lines through the same 2 points. Also remember that the 2 points cannot be the same point. The second thing to remember is that we're targeting intercepts. The y-intercept is the value of y when x is 0, and the x-intercept is the value of x when y is 0. We find those 2 points because it's pretty easy to plug in 0 into equations. Last, we find the intercepts and then connect them to make a quick graph. You don't need to obsess over the major details over the coordinate plane that you draw, right, like for example right here. But it does need to show the general relationship and be accurate enough to create a straight line, or as straight a line as you can draw freehand. I hope you found this video helpful.